Imagine Sparky, the electric field explorer, at each corner of a square. With side length A, Sparky places a point charge with magnitude Q. Two of these charges are positive and two are negative, as shown in the figure. Sparky needs to find the direction and magnitude of the net electric field at the square's center using Q and A. Can you help Sparky figure it out? So I drew the representation of the problem. It was said there that there are two of these positive charges and two negative charges, and there are also Q and A variables. They said that at each corner of the square with side length A, so I put A here, A there, and A there. Now, we need to figure out the net electric field at the square center, the direction and the magnitude, so we can help Sparky. From positive to negative, knowing that the electric field of a negative charge is always inward, then this is going to experience an inward flux, and same is true with this one because they're both negative. On the other hand, this one's positive based on this. It's positive based on the given, and as we can see, this and that would cancel each other out. So we'll be cancelling, don't need to think about them, because this is along our y-axis, then that'll be EY, E meaning electric field. Now, remark, if we all remember, so considering our middle, this would be, let me use this one. Okay, so considering our middle, we've got here like that, and there we go. Now, because we'd like to consider the middle, we need to draw lines that would tell us the electric field's motion. Now in this case, we can focus on one of the quadrants. I can definitely, not that it made any difference, but I divided the quadrant, or I divided the square into 4 parts, making this part here my quadrant. So we can have this one, since this is 90 degrees, assuming this is 90, this is also 90, then it's safe to assume 90, then this should be 45 degrees. It's fairly safe to assume that this one is 45 degrees, and we've got here a right triangle with 45, 90 degrees, which is fairly important to notice that we have here a quadrant, and in this quadrant we have a triangle here, and we see that this is our hypotenuse, calling this our lowercase r. Now our lowercase r will be very handy when we figure out this part here, this and there. Now this is your r, and we said that the whole length, or the whole side, is a. Dividing it into 2, then both of the sides would be called a over 2, a over 2 and a over 2. Now remember that for us to get the electric field, that should be k multiplied to the absolute value of q divided by r squared, but if we do have a vector, we can add our r hat. Now in this case, our r hat isn't available. What we do have is our angle. Now the angle here is 45, since from your positive charge going to the center, or let's say P here, we have a 45 degree angle from your y-axis. And why do we not need our x-axis to be considered here? Because for the for both lengths, the x-axis would be cancelled out. I mean, the fields along the x-axis would be cancelled out. Now, modifying this equation, your EY, because we only have EY, should be equal to E cosine 45 degrees. Now your E given by this one, that's your E, not rewriting it, K Q divided by R squared cosine 45 degrees. That's going to be your EY. Now let's try it. However, upon trying, we would notice that our R squared is missing. How did we get our R squared, given that that is your C in Pythagorean theorem? If you remember, C squared is equal to A squared plus B squared. In this case, that's going to be our R squared, equals A over 2 squared plus A over 2 squared. Simplifying, you'll have A over 2 squared plus A over 2 squared. And that would be A squared, square root of A squared would just be A over square root of 2. So your R would be A over square root of 2. Now, given that, we can definitely plug in the values. And having said that, using this, we can have K as 9 to the 10th raised to 9. And we remember it's nm squared over c squared. So we can leave the units for later. Our q is given to be as, well, this is only q. In this case, we can't find any value of q here. So let's just leave it as q. Absolute value q divided by your r squared, in this case a over square root of 2 squared. Because this is a square root of 2 squared, don't forget the cosine 45. We can simplify it later on. Just putting the k here because k is still a constant. So putting it back there. Now this is the only one that we have because we figured or calculated it based on one quadrant alone. Now we've got 4 charges. We can multiply this by 4. So that would be 4EY. Multiplying everything by 4, that would just give us